Hi, my name is Kelvin Pang Cheng Han. I'm going to demo on my FYP with the title of Stochastic Computing Low Pass FIR Filter Asic Design using OR-gate adders. The objective of this project is to design a stochastic computing FIR low pass filter using OR-gate adders. Conventional binary encoded FIR low pass filter will also be implemented so that the area and power consumption can be compared. And this project uses Synopsys 2. This is the SC OR-gate adder, which means by using an OR-gate I can add two numbers together. And this is FBE and SC representation. So stochastic number is represented in a probability form, which is the number of ones divided by the stochastic length. This is the way to generate stochastic number by using a random number generator, which is the LFSR, and a comparator. And then SC will be converted into BE by using a counter by counting the number of ones. Next, I will start with using Matlab to generate a filter by obtaining its filter coefficient. Firstly, I choose low pass, then design method FIR. I'm using the windowing method, and then I will specify the order to 9. Then this is Hamming. Then I will design the filter, and this is the coefficients of my filter. And next, there is a code using Matlab to verify the result of FIR filter. This is the X input, and this is the coefficients, and this is convolution to perform FIR filter functions. And these are the results that I obtained for my FIR filter. And these results are tabulated into a table. Next, this is the table that is tabulated for the X input and the coefficients. Firstly, the total coefficient is totaled up, which is 1.161514822. And then there are modifications needed for the stochastic computing FIR filter coefficients. Each of the coefficients are divided by the total of the coefficients. After divided, the cumulative form of the coefficients have to be there, which is this one plus this one, and this one plus this one, and this one plus this one, and so on, and until it is 1, which means this is normalized and cumulative form. And then the number of bits we use for this BE and FC filter is 16 bits, and 12 bits and 8 bits also implemented to compare its latency. And next, we will verify our FIR output by using Synopsys, and using this command I can generate the output. And this is the output for binary-encoded FIR filter. This is Y0, Y1, Y2, Y3, and so on. And these results are tabulated in a table. Next, SC FIR filter result will be generated in a waveform. And this is the result of ones produced by Y0, Y1, Y2, Y3, Y4, Y5, and so on until Y18. And it is tabulated in a table. Before that, I am using Excel to produce the result. This is the number of ones. And then the formula is given by 2 times the number of ones divided by 2 to the power of 16, because we will be using 16 bits, and minus 1, and multiplied by the H total, because before this we have divided all the value by H total. So to get the result, we should multiply back, and we get all this result. Next, we will look at the table tabulated for all of the result. As you can see, the SC FIR filter 16 bits are almost equal to the BE FIR filter, and then for the 12 bits, the values in the middle are almost equal. And then for the lower value, that is almost inaccurate because the number of ones they can get are lesser, and they are having lesser bits, and then the number they can represent are also lesser. But using 12 bits and 8 bits, it can reduce the latency of computing a value, because each SC FIR filter requires 2 to the power of number of bits to compute a value. Next, after design compiler is done, we will use ICC to do place and route. And this is the layout of BE FIR filter. On the right side is the SC FIR filter. Then we will proceed to check its congestion. For BE FIR filter, the congestion is shown here. There is 0 congestion for the red color. And then for SC FIR filter, the congestion is also 0 for the red color. There is no congestion between these two designs. Next, for the final part of IC design, we will do prime time. As you can see, the prime time whole report of both of my design are met, and then the timing report for setup also met. And then for the analysis coverage report, both designs have all checks, and it is 100% met and 0 violated for both designs.